Good evening, guys. Thanks for coming. It's been a long day. I know that it's kind of you guys are exhausted with so many things and so many learnings we have seen. There are new things have introduced in the keynotes, and it's exciting to see a lot of new products. And today's title is Securing Microservices in Hybrid Cloud. This is the last session of the day. So after that, there is a hub out. So hopefully, we will try to wrap up and everything in 30 minutes. So we want to cover the concepts, the project which we have implemented using the concept. I'm Kom Subramaniam. I have been with an IT for a longer time in various IT sectors. I'm responsible for digital transformation architecture and API products and management platforms. And I'm also a part of an OSS working group. And my colleague, Senthil.
Okay, first, thank you everyone for taking time to attend this session. I'm Senthil, and I head the Mobile Center of Excellence at T-Mobile. Part of my responsibility includes strategy and also providing technical direction to the mobile apps. We also work on both internal and external partnership apps, and we manage around 20 plus apps as part of the portfolio. A little bit about the T-Mobile. To start with, I just want to give a brief overview of the Uncarrier. So T-Mobile started this Uncarrier several years back in the name of making a wireless revolution for addressing customer pain points. Some of them are eliminating the overage fees and roaming fees, and also groundbreaking plans like T-Mobile One, where you have everything unlimited. As a result of these Uncarrier moves, what we have seen is that the customer base has grown by twice in the last 5 years. And part of the growth is also our network has improved from no LTE to covering almost 323 million Americans in the last 5 years. And also from the customer care perspective, the whole company on the Uncarrier side of it, it has been delivered based on all the things, the outstanding customer experience, and we have also received the recently as #1 wireless carrier in the customer care from JD Power, and also has the highest score for any company in the recent study. To support the Uncarrier, we saw quite a lot of sessions today on the digital transformation. So internally also within T-Mobile, we started a transformation several years back to provide the agility of what the business is requesting in terms of all this Uncarrier moves. The goal is to provide and make things faster, better, and cheaper. The real mission was to increase the velocity as well as improve the quality. And while we do this, we just not only solve the pain points of what we had from the customer point of view, but also internal employees and looking at things, how we do today and how we can radically simplify. One thing I want to call out is the investment on the FTEs. The part of it is how do you keep all your inherent knowledge as well as IPs that comes out of this project, manage it so that you can continue this particular journey. In the last few months, one other big change that was done was that we brought in product and technology together. Part of the reason was that how do you bring in the ownership within one team? So starting from the design to delivery to operations, it's all managed under one leadership. As we embark on the journey of this to being a world-class technology leader, what we started doing was that as we started with the digital transformation, we had quite a lot of learnings and also best practices. We started to do some of the open source projects based on these learnings. And we have several projects that's been in our open source link that I provided over here. And today's title today's topic also part of the digital transformation, and part of it is also sharing what we learned with a practical experience of one of the projects that we implemented. And I'll give back to Combs to walk through the few slides on setting the foundation for the topic.
Okay, thanks, Senthil. So, as I said earlier, the security and microservices and cloud is kind of heavy loaded topics. So we'll try to make sure that we cover the key concepts. First, the initially to get through that answer from starting from the basic and to how we have solved that problem. So from a traditional API security point of view, most of the enterprises, they have a web application level of security. That means the user, when they log in, and the login is that state has been maintained in the server side, that information about that session, the ID is, it's in the browser, it's in the cookie format. Let's say that's a cookie. Every time the request comes in, the JSON ID, it comes in as part of the request, and then request has been validated by a web application server. That's where that session is validated, or request for an authorization is, everything is trusted there. Now from there, the call goes to downstream systems are kind of a trust-based. So basically, you could say that any kind of legacy systems or middleware systems, there are systems, plenty of systems in the backend. They kind of assume that somebody is taking care of that authentication or authorization upfront. They don't need to worry about that authentication authorization portion. This kind of opens up a hole that this web application decides that it can make a call to any services what they wanted it. And also, this is not in a scalable model in a way that if it's a modern web applications where the single page application, it's kind of deployed into multiple applications. When you deploy in a multiple application, the session ID, something we have to have on a centralized storage in place, or something it is distributed. It's kind of that brings in a complexity of how we are maintaining it the centralized, and how in a hybrid cloud scenario where we have two clouds, and how we are going to share that. And also that centralized session management, it is always every component, it makes sure that every SPA application will make sure that whether the session is valid by checking within a remote server. Now, going to the microservices, the microservices word is becoming famous because Netflix and Amazon they find a success with microservices architecture. That's microservice. It promotes independent develop and deployment. It's a main thing. That's what it promotes from the ground up. It's a foundation for that. And also the microservices benefits are scalability and reliability. When we go back to that session ID comparison, you could take it an example of the previous one where we said that it is in a trust-based. You could compare with a real life scenario where you go to a movie complex. First, there is a checkpoint. I think that's what that I missed out here. You go to a movie complex, they check it out the first place, and then after that you go to movie shows. That movie shows are pretty much open. There is no checkpoint at every movie shows. So you can pick any movie show whatever you want. So because the ticket is validated up front, it is not checking that you are allowed to see this movie show. So that is just like comparing it to a trust-based one. But in the microservices world, we would like to make sure that it's a scalable solution what we wanted it. So you could compare with a real life scenario where in an airport travel. I think you are all familiar, I must be familiar with an airport travel. Once you get a boarding pass, that's a boarding pass, they verify that, okay, this is the person, you punch in the number and the confirmation code, and you get the boarding pass information, and then you take it to the next level entry point, is a TSA check. The TSA makes sure that your ID and boarding pass information is good, then sometimes you randomly selected for an additional scrutiny. So that's another thing. Then you go to a waiting zone, and before you get onto the flight, there is another checkpoint where they will make sure that you got the valid boarding pass. This is like in multiple places, every level you have a checkpoint to make sure that the person is authenticated or authorized to get in. That's the same thing we are looking from securing the microservices world, where every entry point we want to make sure that it's a domain level or it's in a group level. We want to make sure that the requests are secure. The request the request, what we get it in, from a scalable point of view, we want to make sure that's a token. Token is something, what we want to make sure is that it's in a stateless. The token can be validatable, self-validatable by itself. Now, the moment we talk about token, it's a JOT, it comes into the picture. It's a JSON Web Token. JSON Web Token, it is formed to securely transfer information between two parties. So that's the main purpose of it. Optionally, there is a validation portion can be included. So to an analogy within a real life, you take your driving license and that informations are printed out there. The driving license information, when you see that, yeah, it's a driving license by taking a look at that. So how we can make sure that this is really a valid driving license? You are looking at through you just flash it on the UV light, you will see the symbol and there. Okay, that's how you are making sure that, yes, this is issued by a valid authority. That's the same thing you can compare within a signature portion. So there are three parts into the JOT. One is a header, another payload, and then another one is a signature. The payload includes the claims about the token. Now, jumping into the next one, so OAuth 2. The OAuth 2 is a user delegation authorization protocol. It's been invented is a secure way to delegate an authorization information to a user for a client apps to exchange your user information from resource services. So there is a group, we actually want to make sure that there is an identity to be included into that. That's where that OpenID Connect came into the picture. So when we introduce an identity layer, OpenID Connect is sitting on top of an OAuth 2, whereas the ID token has been issued as part of an OAuth token. So OpenID Connect deals with two different tokens. One is an access token, another one is an ID token. Access token is it can be an Opaque token, or it can be in a JOT format token. So in cases where if we need a self-validatable informations are required, access tokens are in a JOT format, and also it's signed by your IDP. For ID token, it always should be signed by an IDP, making sure that the user basic informations are included as part of the ID token. I'm just going fast from the key concept. This is really a very deep subject. You can go into the detail about that, but I'm just this is a basic ground set for everyone to know that, okay, these are the concepts. Now, with an OpenID Connect, we should be able to make sure that we can exchange that. We can make sure that the APIs can be called securely. But with our security revision or a group decision made by our DSO, Digital Security Organization, the TAAP is one another approach, or it's making sure that there is an additional security in place. So this is a TAAP process. The TAAP means it's a T-Mobile API access process. It's standardized by a group of people in T-Mobile. TAAP sits on top of an OpenID Connect, where OpenID Connect makes sure that the authorization and identifications are in place. TAAP also makes sure that there is a message level integrity is also secure. That's where that POP token is introduced. So now the question is, what is POP token here? POP token is a proof of possession, which is, again, it's in a JOT format. When the request comes in, every request has a bunch of information can be hashed out and then added to as part of your claims information. So what you see is an EHTS. It's what are the header values we have created that EDTS hash value. That's what you see it in the picture. Now, when we receive that request, we can create that hash. We can create the same hash out of that, and we can make sure that this hash matches with what is an incoming request. That's how we validate the POP token. So who is going to sign this token? The POP token is, it's a client is the one who signs up the token with the private key. It's using the key pair. There are cases where we use an asymmetric, but mostly we recommend an asymmetric approach where we use an RSA key pair, private key and public key here. Now, how the TAAP call flow works. So the first, there are 4 sections in the sequence flow. One is offline client registration, and this is, you can call that as a client onboarding. The next one is authentication authorization, and another one is getting a token. I think this is a part of that. The third one is the functional call. So there are 4 sections included in that. So first one is an offline process, which is an onboarding process. Onboarding process, as I said earlier, we need a POP token from the client. So that's why first initial step is the client need to generate their key pair. Public key and private key, it will be generated. I think they can use that any tool from their wish. It's easy to create from for a key pair. Once you have the key pair, exchange that or provide that public key information as part of your onboarding request. The client information will be ingested, and that's how information it will be exchanged to our identity provider. Now, identity provider, once they receive it, client ID and client secret code is generated and send it back to an email. So that's the client credential information what client has that now. Now, coming to the real-time call, how it works. When the moment the app launches it, it's a login page is thrown, it's redirects to a login page to identity provider. Now, identity provider throws a login page. The login page user credential informations are captured along with the authorization grant also is granted by an issuer. Now, auth code will be sent out to a client app. Now, client app will make a request for a token. That's where the token, it's requesting for a token with exchange of auth code and that POP token from the client side. Now, the IDP returns access token and ID token, both information back to the client. Using that information, client can now make a resources call. So as you see that the access token is the one plus POP token, those two are required to make the services call. Now, this is a simple flow what we describe in the TAAP, how the call would be working. Now, moving to a hybrid cloud, before we move to the hybrid cloud, I just want to make sure that we all understand that hybrid cloud is basically you have applications on both in multiple clouds or more than one cloud or more than one premises. It could be some systems are sitting in on-premise, some systems are sitting in cloud. There are reasons for some applications are not moved to cloud, or there are reasons for there are valid reasons to stay it in the on-premise. So one of the valid reason is the security reasons. Still, some companies don't want to give up that information in the cloud. And another one is it's a time taken or it's a resource is required, too much resource required for moving some of the legacy system from on-premise to cloud. That's another reason. But from a cloud benefit perspective, we have a lot of advantages. During any promotional period or the resources what we want to use or when we want to use, we can scale it up and scale it down. That's another advantage. And when we design application, everything is in a cloud native, you can move around any cloud. For example, if AWS is providing a cheaper cost, you can keep that applications running there. If it is GCP is providing it or an Azure providing it, you can move around your application however you want it. Now, with hybrid cloud, how it would be working the TAAP flow. That's what we are showing it in the picture. The first one is the client application follows the same OpenID connect flow. It sends through that. Then the second one is where that access token issued with the access token and then POP token, it's making a call to an API gateway. That using that API gateway, now it's mapped to an ID token. The ID token information, why we need that ID token information is because our user information in T-Mobile, that user informations are associated to multiple resources inside that. For example, account and your mobile numbers. In a person can be associated to multiple mobile number. There are some basic informations are required to authorize that information. That's why the ID token is ingested as part of the request to a microservices down below. Now this is same information, it's flow through the layer down below. In some cases, some of the applications cannot be moved to this model because they still function within a service level or on a system level account permission. That's where the system will act as using the client credential OAuth2 model. It will get an access token. With that access token, and also it will pass that. That's what the flow and the down below what you see. It's another variety of variants of what you see it here. It will act as a system, and it will make sure that informations are exchanged. This is how we have accomplished that moving that calls back and forth in the cloud side. Now, this is the same approach we have used in the application. Now, I'll give it to Senthil to explain how we have done that.
Thanks, Combs. So Combs set the foundation of how the TAAP is defined within T-Mobile. So in the next few slides, what I'm going to do is that I'll take the practical example of an T-Mobile application and how we have implemented TAAP, and it's a journey of how we moved from an Opaque token to TAAP token. So I categorized as providing an overview of the T-Mobile application to just set the foundation of what the app is, then talk about what are the challenges in using an Opaque token, and then what are the benefits, and we move to TAAP. To start with, T-Mobile app, it's a mobile application, and we have a version of it both on Android and iOS. We have more than like 75 million installs that are in the market today. And a couple key functions of this application are, one, it serves as it can be used as a self-service application, and it's the primary point of contact for the customers to talk to T-Mobile. And they can use this app to do a self-serve, or if they can't find the information, they can use it to message or call. The second function is about analytics. You collect some data within the application, and this data is primarily used for improving the customer experience. And this app collects it in the background and sends back as part of the functionality itself. I just called out these two because in the subsequent slides, there are two different varieties of token that we'll be talking about. One about the user token and a device ID token. And then I have two versions of the app called out. The version 1 that was launched in 2015 that was using an Opaque token, and version 2 that was launched like early this year that moved to TAAP-based process. Just a little bit background of how the data is structured for the T-Mobile app. Combs talked about how the enterprises uses the hybrid cloud for different scenarios. In this case, I'm taking the T-Mobile app. So we have data that's been across different infrastructures. One on the on-prem, primarily any data that is related to the client credentials or generation of the token that's an on-prem. And we use AWS as well as part of the T-Mobile application. And there are two key things that we have in AWS. One, a data that is not customer specific, example, a device related information or like a promotion related information. Those are all in the AWS cloud. And then second function is like it has a list of microservices that's been deployed. And part of the function of this microservice is that, okay, it takes data from different locations and orchestrates for the UI display. And the third component of the infrastructure is that we have restricted data that's primarily within the private cloud. We use PCF, and a lot of this data are related to like your billing information or information related to the specifically for the customer account like lease or it's customer specific data. So I'll be referencing to this hybrid cloud as well as the different versions on this also in the subsequent slides. So just remember like, okay, what are the things that we discussed in the last couple slides. So going to how we did it with the version 1 of the application that was launched previously, we had this Opaque token as the first design of the application. So if you follow the path of the call flow between 1 to 10, that's where you start with submitting the credentials and then getting the data for the app display. So in this case, when the user submits the credentials as part of number 1, identity provider checks for the validity of it, and then it sends the Opaque token or device identifier. Opaque token is used to retrieve the data for the customer so that the contents can be displayed on the app. The device identifier is used to submit the analytics data. I've given examples of the opaque token and device identifier on the right side. So what it's mean is that it's just a bunch of hexadecimal strings, which means nothing for the receiving application. So in this case, let's say as part of the call flow number 3, when you're requesting the data for the application, you send in this opaque token, and the receiving microservice or an application do not understand what that means. It goes back to the identity provider, which issued it, and validates it. And once it's successfully validated, it can retrieve the data that's within that particular infrastructure, in this case within the AWS. But if you're looking for more information outside of it and going to the private cloud, you still pass this opaque token, and the same process happens again, going back to the identity provider and checking for its validity. So what you see is that, okay, we put in a dependency on a centralized system, and every system that is receiving this token needs to go back to the IDP and request for a update for its validity. The couple challenges that I called out using this opaque token was that, one, making a dependency on the centralized system and making a request from every infrastructure, and by physics you're making a new call and there is some additional latency. We have like 100 to 200 milliseconds of latency that you have seen in every call that you're making in. And for a given application, when a request is made, as it goes across the boundary of different infrastructure, there is at least like 5 to 6 calls that's been made. And what happens is that, okay, it increases the latency of overall user experience. And you see the experience, what I called out with the screenshot on the right, like sometimes the user doesn't get a data and they're forced to use the web application instead of the native application. The second challenge is that, okay, the token that's been issued is more like a session token in a traditional way, how it's been used, like Combs mentioned. So what happens is that, okay, the token is valid for a duration, and you go by the blind trust of if the token is valid, then you start giving the data. So there is a possibility, like when the token is stolen, and it can be replayed, and it can be replayed not only with the request for which the application has called, but it can be replayed to get data, any other data that's been protected just by using the opaque token. So knowing these challenges, in the last couple of years, when the TAAP was defined, in the recently redesigned application, we moved to a TAAP flow. So we still use the same infrastructure of how the data has been stored in a hybrid cloud. So in this case, you can pretty much look from the premise of it, like previously we had like 10 different flows to get the data. In this case, only 6 different flows. And you get as part of the submission of the credentials, you get 2 tokens. One for the user ID token that has an information regarding the user. Second, on the device ID token that has information about the device. So I just put an example of how you retrieve a data. In this case, you're using the user ID token. So when the user ID token is received by the microservice in the AWS, what it does is that it does a self-validation. It can just go retrieve the public key from the identity provider using the JSON web key, and then validates it. And once it's successfully validated, and passes just the user ID token to the subsequent cloud as well, and it also does the self-validation. And as part of the TAAP process, we also define this POP token that Combs explained, which is used for integrity protection. And probably I can cover a little bit detail in the next slide. But overall, in this particular slide, what I want to cover is that it removes the dependency going to a centralized system, and pretty much every microservice, by definition, it's self-contained, and in this case also do the security of the validation by itself. Here are the 3 tokens and an example of how it's been used in the T-Mobile app. I just masked the values, but in general, the structure is what's been put over here. In the case of device ID token, you primarily get the identification of the device, in this case, the hardware ID, and it's going to be the phone number. And in the case of user ID tokens, you get some basic entitlement information about the user. So I call out examples like, how many lines do I have in my account, or like what is the plan type. These information can be used at the microservice to determine certain decisioning. Say, for example, on the mobile app, since the real estate is going to be smaller, you don't support more than 20 lines. If it is more than 20 lines, we redirect to the mobile web. So these decisions can be made as soon as the request is received, because you trust the token, you trust the values that are coming out of this ID token, and you don't want to make any of the downstream calls to wait for the redirection at the user end of it. Proof position, it's primarily used for message integrity, as was explained, and I called out like the list of headers that's been used for the app data request, And these header payloads, we use it to generate the signature, and it comes as part of the EDTS, which will be validated. Example of how the TAAP is used over here. When there is a self-service request to get the data for the application, we use the user ID token along with the POP. In this case, if you go by the sequence, you first validate the signature of the ID token. Once you successfully validate it, you just extract the public key of the client and then go back and validate the signature of the POP token. And then you validate the hash of the POP token. And once if everything is valid and it's looking good, then you use the entitlement, or in this case, the ID information of that particular user for the self-service request. For analytics, the same process happens. At the end, then you start using the ID information of the device. So you know, like, okay, this application is used on certain device type and what is the phone number associated with the device. The benefits that we have seen is that, one, improved experience. We talked about removing the dependency on a centralized system. So doing that, we are taking the IDP from the critical path of the experience. And also, like, we are able to reduce the load to downstream to a certain extent, because we pretty much know, based on the basic profile information, you can make a decision of which calls to be made, or if certain calls need not be made, you can make those decisions at the microservice level. And with the digital transformation of moving from monolithic to microservices, I mean, we have different domains as part of the enterprise, and there is a flexibility, like if a domain decides to put additional security and if it wants to be an IDP, then the overall framework and the architecture allows to integrate to any specific IDP. And also, like, self-heal, because when there is a key rotation at the IDP to change from the RSA key pair, then you don't want to have any coordinated effort, because based on GWK, you just go receive the most recent public key and continue the same process. And finally, improves security, because the POP tokens that you generate is used for integrity protection, and its duration is very small. When you try to make a request to retrieve other data, then the signature may not match it, and then you just try to protect from the POP token. So I put an example of a metric of from the T-Mobile app perspective, what he has seen as an improvement from the performance. So with the Opaque token, the app load time was around like 3.2 seconds, whereas with using the TAAP token, by reducing a dependency and also reducing the downstream calls, we're able to bring it to like 2.5 seconds. So it's almost like 20% improvement in the overall experience. I think that's my last slide. Happy to answer any questions that you have. Yeah. The question is, in the initial slides, there was a client signature. So can I know which slide are you talking about? Okay. Is the one this one? Okay. All right. Yes, so if you look at the POP token, right? So in the POP token, if you look, there is cpriv is the client private key that we use for signing it. So runtime, you generate an RSA key pair, and you typically use the device capability of generating an RSA key pair and store it in the device key store. And then it's going to be individual per device, and it's not something that we have embedded in the code. So you pretty much use the client private key and public key. They're specifically used for signing off the POP token. I'm talking about mobile handsets, yep. Exactly. Okay. Yes.
So in the flow where there's two microservices,
Mm-hmm.
and they both get the same token, right? It flows through, right?
Yes.
Is the claims then asserted on each of those, like going to be the same, like they're both looking for a T-Mobile user or something like that? So even in the protected area, maybe in the private cloud, you're looking for like a T-Mobile user claim on a token?
So what we have implemented as part of phase one, the claims are going to be the same. So you pretty much are looking for user information related data for taking it to the UI. We haven't put specifically changing the claims based upon which infrastructure you're adding in. But if you look at what Combs explained in the last slide of how the TAAP can be used in taking a different, on behalf of the user or based upon microservice itself is acting like a client, it can retrieve a token and make some additional requests if required. Does that answer your question? Okay. Yes. Yes.
So the question is how we are doing the client registration. Right. Right. So I think there are two things, maybe just making sure there are two distinctions we are making it. So that there is an app itself, it can generate its own token. That is for a POP token. But if it's from the client side flow, for example, the T-Mobile APIs, it's invoked by a third party, or somebody is developing an app, they want to make an API call, it is from their server. So that client, or like let's say some third party developer app, they have to register with T-Mobile API through an API developer portal. They have to register with their public key and the client information. The information, what we send it back, exchange it back, is in a client ID and secret code, just like in any other portal sites. Right now, we are sending it through an email. That process will be in a self-served, just like in any other portal. It will be visible for the user at the time of registration pretty soon. But right now, the process is sending an email within a client ID and then a secret key through another developer. Yes, that's right.
Just to add what Combs mentioned, specifically on the mobile handset, it is a dynamic registration. So we use some of the device capabilities like push notification, relying on a channel that we can know it's secure. And that's part of the proprietary thing that we implemented, and that's part of the TAAP process.
Yeah.
So when client get the token, right? It's the identity, and how long do you keep the token valid? And how do you, for instance, if you need to bring something, you have something like a remember me feature.
Yeah.
And if that token became expired, how do you automatically update and keep the client in sync?
Yeah.
They don't have to log in again.
Yes. So question is that when you generate a token, how long do you keep it valid and how do you refresh the token? Do you have keep me logged in feature? If you just look at the screen, and I know if it is very intuitive, but just before the password, there is a checkbox in the login screen. There is a keep me logged in option. So there are two things that happens. One, the user can log in, and if the user chooses to keep me logged in, we keep it for 90 days, the session, but it's not like token is issued for 90 days, but in the background, we refresh it every time the app is launched. Second thing, we have the capability of introducing the biometrics for login. So they register for biometrics as part of once the login is successful, they can use it, and every time they just validate the biometrics, then it also initiates a process to refresh the token. So we typically keep, based upon the use case, anywhere between 10 minutes to 15 minutes as the validity for any of the token that's been issued.
So after 10, 15 minutes, if the client do something with the app, they will get another token.
Exactly. So every time when the client, there is a module, we call it as a connection module. The module, when it tries to make a request to the backend and when it tries to generate this POP token, it checks for the validity of if the ID token it has received is still valid. If not, it makes an automatic refresh and then it generates the POP token.
So how does the client receive the new token?
That is, again, part of the auth process. We have this auth code and session ID that's been managed.
So, yeah, that is a refresh token comes into the picture, right? So the refresh token, if you are following that authorization flow, grant type, the refresh token will be used to refresh your token. If you are using that just as on a server side, it will be just in a client ID and secret. There is no refresh token in case of your servers is acting as a server. If it is on behalf of user, there will be a refresh token. So it's based on the grant type flow, we issue the token. Is that answers your question? Okay.
We do not we invalidate based upon there are two ways of invalidating it. One, if in case you see you want to invalidate all the requests, you go and change the keys, rotate the keys on the IDP. And the second invalidation is based on the duration, but there isn't any specific mechanism that you have defined for invalidation. Did you see a scenario wherein that you want to invalidate? Yeah. Right. And the way we do it is like we just go and rotate. Right. So in that case, we just rotate the keys on the server side. So when it is trying to be used at the server, we have a different signature. How long it took you to use this 3 to 4 months?
Yeah, I think the TAAP is kind of evolved based on how we used to, we still have some applications uses the OAuth 2, and we moved to an OAuth OpenID Connect. And then recently we introduced the TAAP process. So it's been a kind of the journey from OpenID Connect from TAAP kind of forming out like 2 months, something like that. Yes. Yes, it is a process in place because we are not calling it as a protocol, because it's an OpenID Connect and sitting on top of OpenID Connect and making sure that additional security added to that. That's why we want to make sure that there's a kind of calling it as a process. Anyway, this session, they want to close it, but I'm happy to answer any questions here. We can talk.
All right. Thanks, everyone.